Hi everyone, I hope you're okay, and I hope that the videos we keep uploading are helping you out. On this video guys, I'll be tackling the 10th question from the mid-year examination, which was written in the province of KwaZulu-Natal in the year of 2024. Yes guys, this is the last question on our mathematics paper 1. Please do expect 10 videos. Each and every question will have its own video. And please guys, do take this seriously. Knowing how to tackle exam questions, I strongly believe that it will give you an edge whenever you write your mid-year exam, preliminary exam, and most importantly, your final examination. So guys, please do share the video to your peers so that they may have the same edge as you. And please do help us grow the channel by just subscribing. Okay. The managers of a zoo are planning to build a fence around a crocodile enclosure. The sketch below shows the shape of the enclosure. The length of the straight section will be x meters each, and the radius of the semicircular end. The length of the straight section will be x meters each, and the radius of the semicircular end sections will just be r meters each, as shown in the sketch below. Okay, the total area of the enclosure will be 400 square meters. So they want us to show that x is equal to this thing over here. Okay, what do we know? I have a rectangular shape over there, and I have two semicircular ends over there, and I was told that the distance from the center to the circumference is r. That means I also have r over there, and r over there, r over there, and also r over there. Ne? Okay, so for me to find x, I must simply find the total area of this enclosure. Are we together? So I must find the area A1 of this semicircle, area A2 of the rectangular part, and then area A3 of the other semicircle. Whenever I add these three areas, they must give me 400 square meters. Are we together? Okay. So area 1 will simply be 1 over 2 pi r squared. The area, guys, of a normal circle is just equal to pi r squared. Are we together? But we are dealing with a semicircular end, half of a circle. That's why the area it's 1 over 2 pi r squared. Are we together? This is the area of section 1, and then this will be equal to the area of section 3. Area 3 is also equal to half pi r squared. This is also a semicircular section, that's why it's half pi r squared, right? And then area A2 is basically equal to length multiplied by the perpendicular height. Our length is x, and then our perpendicular height is just 2r. So this thing is basically 2r multiplied by x. The area of this part over there is 2r multiplied by x. But what was I told? I was told that if I add these three areas, I must get to 400. So let me just do so. I'll simply say the total area should be just area 1 plus area 2 and area 3, right? The total area is just 400 square meters. Area 1, it's half pi r squared. Area 2 is just 2r multiplied by x. And then area 3 is also half pi r squared. Okay, this will simply give me 400 is equal to half pi r squared plus half pi r squared will simply give me just 2 pi r squared. And then I still have plus 2rx. I'm looking for x, ne? That means I must just isolate to x. But before I do that, I must take the pi r to the other side. That's 400 minus pi r squared, this is equal to 2r multiplied by x. If I divide both sides by 2r, therefore if I divide both sides by 2r, I'll therefore end up having 400 minus pi r squared all over 2r is equal to x. Now I've proven that x is equal to that. Okay, and then I'm supposed to show that the length of the fencing L can be expressed as this over there. The length of the fencing. They just want us guys to find the perimeter of this entire shape. Yeah? How can we do so? The perimeter of our entire shape should be simple. Should be simple. We are just going to add the length of x over there and the length of x again, and then find the length of our semi-circumference. Are you together? The equation for finding the circumference of a full circle, is basically 2 pi r, but the circumference of a semicircle is just equal to pi r. Are you together? So the length of this part over here, the first semicircle is just pi r, and also the length of that other semicircle will just be pi r. Are you together? And then for me to find the total length, guys, I'll just indicate it over here. I'll just indicate the total length. I'm just focusing on the outer part of this enclosure. Just focusing off the outer part of the enclosure, right? This red part is just equal to pi r, and also this one is also equal to pi r. Are you together? Please keep that in mind. You know? So therefore, my total length will simply be 2x, because it will be x plus another x over there, right? Plus pi r plus pi r, which is just to 2 pi r. Are you together? But remember that, guys, I know the value of x. I do know the value of x. The value of x is simply 2 times I have 400 minus pi r squared all over 2r. I still have, I don't have enough space to write there. Let me write there at the bottom. LR is basically 2x plus 2 pi r, right? But remember that I do know the value of x. X is just 400 minus pi r squared all over 2r. 200 minus pi r squared all over 2r. I still have plus 2 pi r over there. Okay, so this will simply give me, I know that these two will just cancel one another. I'll be left with 400 minus pi r squared all over r plus 2 pi r plus 2 pi r, right? Okay, all I can do here, guys, is to just add these fractions. My LCD is just r, so I'll just multiply both terms by the LCD. Whenever I do so, I'll end up having 400 minus pi r squared plus 2 pi r squared. Because whenever I multiply this by r, I'll simply get to 2 pi r squared. Ne? And then this will end up giving me 400. Negative pi r squared plus 2 pi r squared will just give me a positive pi r squared all over r. So I now know that the length is basically equal to that. Our length is equal to that. Ne? You can separate you can divide both terms by r, guys. Ne? But this and this are the same thing, because you can further say this will be 400 over r plus pi r squared over r, and then the r's will just cancel one another. You'll be left with 400 r plus pi r. Altogether, this and this is one and the same thing. You can take it further until you get here, but it's one and the same thing, né? Okay, and then now you're supposed to calculate the value of the radius that will ensure the length of the fencing required will be a minimum. Okay, will be a minimum as to minimize the cost of building the fence. Since we now know that the length is basically equal to 400 r plus pi r. Once I come across this term over here, that means I must find the derivative with respect to r, and then solve for r. Together, make the derivative equal to 0, and then solve for r. But before I find my derivative, I must make sure that this thing is removed from the denominator. So L of r is just equal to 400 multiplied by r to the power negative 1 plus pi r. So the derivative will simply be negative 400 r to the power negative 2 plus pi. Are we together? And therefore, remember that the derivative should be equal to 0 for at minimum, and therefore I'll just be left with negative 400 divided by pi r squared plus pi is equal to 0. Are we together? So that's negative 400 divided by r squared is equal to negative pi, and then r squared, I can just cross multiply, will be equal to 400 divided by pi. So I can just take the square root on both sides, and then this will simply be the square root of 400 divided by pi. Pi, you can just press shift, and there's a button there, guys, at the bottom of your calculator, which is in the middle. It's written times 10 to the power x. After pressing shift, just press that button. You will see pi will appear there, né? Then press equal to, your radius will just be 11.28 meters. This will be our minimum radius. That's how, guys, you're supposed to tackle that question over there. So please, guys, do help us grow the channel by just subscribing, né? And please do share the video to your peers. And please, guys, I repeat, do take this seriously, because knowing how to tackle exam questions will give you an edge. Okay, bye.